go figure this out. USB digital audio it is?
So let's send out.
Yes. Yeah.
Once it gets. My only problem is and if I like 54, I didn't have 5 but I got 50. You know what? Yeah. And use a little more filter. It's not as hard as.
Oh, geez.
I envy you when you find out.
Why do I not have a signal? It's pretty late. Okay, here's another test. I'm going to define what thirds.
It's a bit.
I'm not exactly sure how much. Spoke too soon, Josh. Now this isn't working. Uh-oh. The thing that always worked isn't working now.
It's pretty garbled.
It's there. Yeah, sounds about right. Like it's not good, but it's not like you can hear what people are saying, but it's not good. Yeah, about as good as I've gotten it so far.
No, you can, it's legible. It's understandable.
Yeah, like it's a little bit, a little bit.
Nature.
Maybe we just lean into that and start talking that way too. Okay, what are you doing? Jeez, I don't remember how to use this thing. Okay, we're doing things now. Okay. I think we rolled the video. Okay. This is probably. I think we can start down. Just slides. Amen. Okay. Okay, everybody. Hi. I think we're going to go ahead and get started now. Looks like most people are here. If not, they can triple it. No big deal. So thank you for coming to Web Devs this month. Before we get started, like I want to do all the time, I want to thank IDX for the space and the soda. Take 20 ideas. I always encourage you to be taking time to organize your things and work with speakers and whatnot to have this part of the community. Also, one thing I want to mention, something I'm trying to do with the Web Devs repository is set up a page with nothing but links of open source projects that are by people here in Eugene. Somebody is a maintainer here in Eugene. So I've got a bunch of small projects, or some small projects there, but Markdown is one of them. I have another one there that's a GitHub search users by location. These are very unfinished, or at least mine's very unfinished. And some things are very unfinished with a label that says good first issue. This is for anybody who wants to get started contributing open source. This is a good first time if you've never done it before. The GitHub forking flow and all that stuff. There are links to docs and all that. So that will be on the Eugene Web Devs GitHub repository under resources. If you want the link, hit me up. I'll post it on the meetup, this meetup on meetup.com as well. So I think that's about it for my thank yous and whatnot. So I guess we could just jump on in with Josh.
Okay, so I haven't spoken in front of people for like 10 years. So I'm probably going to start out really nervous and then get like. So, welcome to my talk, unit-based development, or how I learned to stop worrying and love unit testing. But before we get started, just real quick, you don't have to participate if you don't want to, but raise your hand if you write automated tests for your code, whether for work or personal or whatever. All right. Now, of you who are raising your hand, keep your hand raised if you write those tests because you want to and not because you're forced to by your job. Cool. And then of those people, how many enjoy writing unit tests? Okay. My hand's still up at least, so hopefully I'll be able to explain kind of why over the course of this talk. So yeah, but first, who is this guy? Who's standing here? My name is Joshua Evans. I've been coding since 2012. Started in college at LTC. I worked at a small business for 4 years as their only backend developer. And I've had to figure out a lot of stuff on my own. And by figure it out on my own, I really do mean figure it out by own. This is not, what I'm going to be talking about is not a known standard. There is no supplemental reading. My source is that I made it up. So that being said, let's begin. So first, let's start with the good old automated testing pyramid. This has been, I totally forgot to pull out my notes. Made my notes. Yeah, the good old automated testing pyramid was introduced by Mike Cohn in 2009. And let's see. Yeah, so pretty standard. Unit tests at the bottom. Unit tests are fully isolated from other systems. Integration tests right above them. Combine those systems together and test the interaction between those systems. And then end-to-end tests check for functionality of the whole program, usually via some kind of AI or not AI, GUI or something like that. As the pyramid shape suggests, you should have more unit tests than integration tests than end-to-end tests. And I think the automated testing pyramid is a perfectly accurate technical definition of different types of automated tests and their desired frequency. But I think it could be lacking a bit as a practical definition. First, there's a question of how do you fully distinguish between integration and unit tests? There are obvious cases, like if you're getting data from a database, but there are less obvious cases, like if you're testing two different pieces of code from different namespaces in the same project. Right? This is a small issue, really not a big deal, but it can lead to organizational conflict and confusion. Also, it has a tendency to become an ice cream cone. It's a good old software testing ice cream cone anti-pattern because, right, well, manual tests are the easiest to write because you don't have to write anything, you just do them. And end-to-end tests, they actually test the things the client cares about. And then it can, beyond that, be difficult to break code down into smaller integration unit tests if the code was not designed with that kind of testing in mind. And then lastly, but I think most importantly, it conceptually isolates testing from the rest of the development process. So this means that, right, I think in a lot of our minds, especially starting out before we're really introduced to testing as a paradigm, in our minds we consider writing code and writing tests sort of two different tasks. And that can often result in there having to be a context shift between writing tests and then writing the code and stuff like that. I really cannot stress enough, I think anyway, that conceptually isolating tests from production code is a recipe for disaster. Okay, well maybe disaster is a bit of a strong word, but it can mean that testing is the first to go when under time pressure. It can mean that testing code is not held to the same standard as production code. And failing tests, this is the big one, failing tests that don't actually break higher level functionality are often ignored, especially when there's time pressure encouraging people to ignore them. So with that, enter test-driven development, right? So I think it's a fairly familiar sort of paradigm by now, right? You start by writing the test, then you make sure the test fails, then you write just enough code to pass the test, and then you go into the refactoring step and do more refactoring, make sure your tests pass, fix tests that fail, keep going, keep circling until you're done and you're satisfied with your situation. I think it solves a lot of the issues with the sort of pyramid because it starts the process with the unit tests, so that means there can't really be confusion about where tests should go because they are sort of like the atomic units. And because tests are the atomic units, it makes it easier to keep the pyramid at the correct shape, right? You're probably going to have more unit tests than integration tests than end-to-end tests. in the system. And then it's also makes testing a core part of the development experience. So test code will naturally be written more carefully. But I think that test-driven development, as sort of laid out there, has some issues. First, and I think this is kind of like the biggest point, it can be really hard to write tests for the code a lot of times. I think a lot of times we aren't exactly sure what the result of an operation should be before we start writing, and there's really no place in the TDD lifecycle for this kind of experimentation. Like, for instance, if you're working with an unfamiliar API and you're not quite sure exactly what the result will be, it's going to be really hard to write a specific test before you know what the result is going to be. Let's see, it also can invert the quality of test in production code, right? Because if the metric for success is a green checkmark, then you're going to code for that green checkmark. I'm sure most of us would normally not code for the green checkmark, but when push comes to shove, and it's 6 o'clock and you're supposed to be gone at 5, the checkmark becomes king. And then it can also add administrative overhead, like if you have to approve tests or get tests written by somebody else, then it can slow down the development process significantly. And then also, finally, the rigidity of the process can be difficult for some. I mean, like, just look at this. It just looks complicated. It's like I'm looking at the Kelvin cycle or something over here. This kind of apparent complexity, whether it's real or not, can seem intimidating, which could make getting organizational buy-in a lot more difficult. So there's still some problems to figure out, and it was in pondering solutions to these problems that I started to come up with unit-based development, which is an extension of test-driven development with a focus on practicality and adaptability. And let's start with the testing pyramid. So my suggestion, basically, is to extend and modify the pyramid so that it's looking like this. It looks like this. With this, update the units, which are the actual core pieces of functional code, are at the bottom of the pyramid. And then unit tests above those are tests that test those units. And the unit test could be either local tests or remote tests, and we'll get more into that a bit later, but there's a heavy preference for local tests. And end-to-end of manifest are the same. I don't really have an opinion as far as this one. So those don't really matter. So that's the pyramid. So what exactly is a unit? Well, a unit is generally a function that performs some specific action, and it looks like this. First, we start. The function itself has no internal state whatsoever. Every function call is just like every other function call, right? It should be idempotent. Good vocabulary. And then it accepts inputs in the form of parameters, including any relevant state data that it might need to perform its operation. So a lot of times, this will be in the form of like an SDK. Like if you're dealing with so for instance, if you're doing a database operation, instead of like creating some kind of class or data structure where you initialize the function with access to the SDK, you give the initialized SDK to the function, and then the function uses that to do its thing. And then finally, not finally. And then it returns outputs to the user or to the original caller of the function. And then finally, it can also perform external operations or side effects, such as getting data from a database or communicating with an operating system or something like that. And generally, we want to minimize the number of external actions any particular unit is making. So ideally, there will be one external action per unit, but that's sort of an ideal. So there might be more, and there's often less. So that being units, unit tests are any tests that checks the functionality of a unit. There is no distinction in this sort of paradigm between unit tests and integration tests. So what about integration tests? Well, modern tools like Docker and GitHub code bases make the distinction mostly irrelevant, I think. Back in the far distant past of 2009, developers would need to either maintain resource-intensive VMs of their environment or make their local environment match the production environment or have like a physical box or something like that. And so the distinction between integration and unit tests, I think, was important and valuable, because if I don't need to spin up my giant VM to fix this code, I'd rather not have to, right? But these days, a single Docker Compose file, for instance, can be used to easily set up a production managing environment for pretty much anybody with a single command. So specifically, what I like to do, so this is some VM that would go inside a Docker Compose file, sets up the, it sets up a Postgres V11 database, is available at the regular Postgres port. Fun fact, Postgres V11 is actually the latest currently supported by AWS Aurora, which is quite frustrating, to be honest. But speaking of AWS, we can emulate some of the functionality of the cloud service using local stack, as pictured here. Specifically, I'm setting it up to use the S3 service. And Azure and Google Cloud Platform also have some local stack-esque stuff available, but it's not really as well supported, but it does exist. And finally, I use these NPM scripts to simplify spinning up and tearing down my environment, critically including deleting any volumes that were created by Docker, because that's the allegation if you don't do that. So using these tools, or tools like it, I think we can mostly do away with the distinction between integration and unit tests. Mostly. So sometimes you can't run external system flow for whatever reason. So while local unit tests can be run on a single machine, remote unit tests are run against non-local resources, usually over the internet. And local tests should always be preferred, but sometimes remote tests are required. And remote tests, right, because remote tests can take a very long time to complete, especially if they are touching something over the internet. And so to handle this, what I like to do is separate the remote and local tests. So typically only the local tests are run, and I run the remote tests only when I want to. And in Jest, I can be even more clever and mark remote tests as skipped when they're not being run, which is what this code does. So that way, when I run all the tests, they appear, so when I run all tests, including remote tests, they appear as passed here, and then when I just run the local tests, it does mark the remote test as skipped, so that the total number of tests isn't actually reduced. Or at least it's marked that there are some tests that were run. And yeah, with that said, let's move on to the unit-based development pipeline. Of course, we got a new pipeline. It's a paradigm. So first, we ideate, figure out what we actually want to write and the units that we're going to need to do the thing we need to do. Then we step out and write the unit, we stub the unit out and write the function level documentation that describes what we need to do with that unit. And I'll get into more detail on all of these things. Then we write the code, writing tests, running tests, writing functionality, and refactoring are all done more or less simultaneously, and we'll sort of get into that in a little bit. And finally, once we're satisfied with all of our code changes, we perform final validation by running any higher level tests or any slower tests to make sure that every single thing still works exactly as we expect it to. So going into a bit more detail, let's see here. The first step, right, in any development task is to figure out what we want to do and how we want to do it. So mainly this involves, right, figuring out what units we need. So once we have figured it out, the next step is to stub out the units that we want to make. So here in this example, I've stubbed out the initialize database function. It doesn't do anything at all. It doesn't even return anything. It's completely empty. But it is fully documented in human language. And don't worry about reading what it says. And so I know what this unit is supposed to do. So now I need to make the unit actually do it. Right? So when it comes to actually writing the units, we jump right between writing tests, running tests, and writing units as needed. And it's always preferable to write the test first if we can, and it also feels really cool when you can write all the tests first. Makes you feel really smart. But a lot of times, as I sort of explored before, we have a hard time doing that. It's difficult, and so it's not required. You can jump back and forth between writing tests and writing functionality as needed. In fact, when I am doing development, and don't worry about the words, it's just the shape that matters, I'll actually put the unit and the unit tests right side by side in my IDE so that I can just jump right between them. And generally, what I'll do is make it so that each unit has its own file, and each unit test has also its own file next to the unit in the file space. And so I can just jump back and forth between tests and actually writing the code really easily without any kind of context shifting. It just flows naturally one into the other. I also use the, I'm sure there's other extensions and other languages that this would work in. I know C# it would work. But I use the VS Code Jest extension to automatically run the relevant tests whenever any changes are made, which is what these tiny little green check marks are. Every time something changes, my IDE will automatically run the unit test. So I'm constantly running unit tests over and over and over again. And organizing the code like this also makes debugging a lot easier because we can debug against the unit tests themselves. So if the unit is not working as we expect, it's quite easy to just put a breakpoint on the unit test, run the debugger through the unit tests, and then we can fairly easily figure out at least what the state of the system is, if not what's actually going wrong. So yeah, it's also extremely important, extremely important that the unit tests that are written are actually good unit tests. Because with this development style, there will be a lot of unit tests that are made. And if they're not good, then you're going to have a bad time. And to me, the most important aspect of a unit test, really what defines a good unit test, is that unit tests must not make any demands on the internal logic of a unit. With the unit tests, so something like requiring that a particular function is used or something like that, right? A particular function is used in a certain way, or having any kind of internal knowledge of what's going on in that unit. Because when unit tests do make these internal demands, non-breaking changes that don't actually affect the functionality of the unit can start to break unit tests. And that is the death knell of unit testing. When you make changes, nothing is broken, your end-to-end tests and all those still work, but you got these unit tests that are poorly written, have some kind of, they're complaining about something you changed, it doesn't matter, they just get disabled, right? And give them time to actually. So therefore, and this is hot take alert. Therefore, mocking is an anti-pattern. That's a hot take for this one. So take this code, for example. It's fairly simple as JavaScript code goes. We're just taking an object, stringifying it, putting it in S3. But if we wanted to use mocking so that S3 wasn't actually touched here, right? We would mock the S3 SDK.send function, right? So we would overwrite that function, replacing it with a simpler method that makes sure we're using the put object command correctly. However, if we do this, then this changes what the unit test is actually checking. Like this unit, right, is meant to, this unit is meant to put an object into S3, and we know that it works if there is an object in S3 after the unit is run when there wasn't one before. But when we mock these internal functions, we change the unit test so that it's no longer verifying the higher level functionality, but now instead the unit test checks whether or not you're using S3 SDK.send in this very particular way, right? And so should we change the method that we're using, or should we use a different SDK, or should we use a different command? Then if we were want to do mocking with this function, then the unit test would break, even though the functionality of the unit may not be affected. And so I think it's generally better to avoid mocking whenever possible, to avoid this kind of situation where you do get this internal knowledge of what's going on in the unit test. But nothing is set in stone, right? Sometimes you gotta use mocking. My question will be again. Sometimes you gotta use mocking, right? Sometimes you can't get something on a local environment, and it's unacceptable to actually use a remote test. And so that's cool, that's fine. But just, I think that's really something, I think a gotcha that could cause issues with sort of this kind of systems. So yeah, so that's writing. That's actually writing unique code. Refactoring is also part of the code writing process, of course. Refactoring, right, it's also done at the same time as other code writing. However, refactors should only be made from a clean test state, right? So if we're going to change existing code, it's important that all of the existing tests pass before you start messing with that code, or else you're not going to know whether or not the changes that you made actually caused it to break, right? And so, yeah, so it's still part of all the same stuff, but we just need to be a bit more careful about what we're doing. And so we can't really jump between refactoring and writing new code unless we have all of our tests passing before we start the refactoring process, generally. And then finally, we have final validation. So once all of our code is written and our fast running tests pass, we run all tests, including end-to-end tests and remote tests or manual tests or whatever. And with the final result being, that was the wrong button. Coding bliss. All the unit tests. And yeah, I mean, that's sort of it, really. Details to dive into, but those are sort of the core ideas. This big old QR code on the screen here links to the public GitHub project that I made that has all of the code snippets in the presentation in their original context. And you should be able to just download the project, run the npm docker upscript, and see it work. So yeah, and then finally, I do want to acknowledge, and this I think will be the interesting point of discussion, that there are some serious gaps in my experience with this paradigm. So this has worked really well for me, I think personally, but I am a solo backend developer, and so I don't actually know how this would work in a team environment. I think it worked, but I don't know. I've never tried it. And I also don't really know how this works in a front-end environment because I'm a backend developer, and this is kind of my thing for that. So so yeah, I'm really excited to hear what people's thoughts might be, and yeah, that's it, really. Yeah, questions. All the questions.
So if you don't want a dependency and inject it with dependency injection, how do you test non-happy?
Oh, non-happy path, yeah, mock happy days.
So you have to mock if you're going to test your
Probably. Well, yeah, it's the non-happy path is hard, right? That is a hard one. So probably with that's probably what and that's kind of the thing here is that part of the big aspect of this project is it's like rules are rules until they're a pain in the butt and then they need to go away, right? And so I do think that mocking is generally an anti-pattern because it creates this effect, but it's still that doesn't mean it's not a useful tool when it's needed and when it's justified.
I was sort of building on that. I wonder if it would be useful to make a distinction between mocking, as in dependency injection, providing a function that is a simplified version, versus testing whether that function was called. So it could make sense to say, okay, well, here's where I would pass in the way to use my external resource. I'm going to pass something that I can just use a local resource instead. That by itself seems like that would still fit with this philosophy, but it maybe would not if you are then testing, was this function that I passed in called with these parameters?
Yeah, so yeah, I think that it's sort of it really it does depend on the situation, right? And I think that there's multiple different ways of mocking, right? There's the functional mocking as I explained, but there's also like the idea of just like mocking up like a full database with you can mock your REST API or something. Use that, and that's also that's great because then there's still no internal knowledge. You're still just checking the side effects. But yeah, sometimes I have done things like if a function is supposed to console log, for instance, when an error happens, like I can check that console log was called, and I can see what that log was. So that is kind of something that I'll do. But console log is like a really standard thing. So I think that the danger of us suddenly being like, actually, let's use a different function for logging is quite low, though it still does exist.
Building a memo product, 2 points. One is testing of apps, the very destructive operation. You want to be sure it doesn't happen or get invoked in very specific contexts. You have to be able to do a mock and assert in the test that that function was. And it's really difficult if you don't that allows you to assert that something wasn't or that wasn't called. Second point, the pattern that I usually see like in enterprise environments is if you have that S3 SDK or the S3 client, you don't directly call it in your logic. You have like an S3 service that wraps it, so you can vary your S3 client without changing the contract in your business model. And so you go through that service class, and it has an interface. If you're working in a language without interfaces, stop. But you can just, most modern languages now, you can say, this interface, I'm mock for it. I can say X when given Y, and I can assert times it's called, things like that, and not have any internal knowledge of how it works. I just say, given this input, give this output, it's called 0 times, it's called 1 time, it's called n times, whatever. And you mock that service class for that interface. And if you change your interface, you just run the mock gen and you have a new mock.
How do you test the interface though?
when you say test, like test that service class.
Yeah.
You then, if you really want to, you don't have to. A lot of places will skip this part. You can then just mock or write an interface for the S3. And you just generate a mock for that. And then that's more concrete. When you change your client, you're only changing the unit tab, changing the logic in that S3 class, or that S3 service class, and you're changing that one unit test, not everything else.
Yeah, that sounds good. Yeah, no, yeah, that does make sense because yeah, it's all about wrapping other people's stuff in your own stuff, so that other people's stuff doesn't mess with your stuff.
Change A1 to B2, something.
Yeah.
So I'm a total heretic. I've written no tests on a single man project that I've been working on, and let's just say like I'm interested in your world and I'm interested in doing test-driven development. Let's say my project is 95% querying APIs and manipulating that data. I know as I'm adding features, I'm getting new API points. I don't know what I'm going to get. The IDs, the unique IDs that I'm getting back for my data merge. Sometimes they come in as a string, sometimes they come in as a number. How would a person like me, if it's possible, do test-driven development if I don't know ahead of time what format the data that I'm going to be getting back comes in? What would you recommend for someone like me who's interested in the idea of test-driven development that just doesn't seem practical given what I'm doing?
Yeah, so that's kind of what like this I think this pipeline kind of because it's not this unit-driven development or unit-based development is not, it's like an extension of test-driven development that's kind of more wishy-washy, I guess you could say. And so the idea is that we prefer to write tests first if we can, but we don't have to. But also I think one aspect that's really helpful in this is that the unit testing space sort of becomes just like a sandbox. Right? So I think probably most of us, when we started coding, right, was like with console applications, and just like you would, run your console application, see what it spat out. But in situations where like we don't know exactly what our API is going to look like, then we could just use the unit test space as a sandbox to do that kind of manual testing and manual checking before we like fully solidify our unit tests to enforce functionality. Right. And so I think that's like I have to do like that's actually the exact sort of situation that fully led to this kind of thing, and especially the idea with like remote tests and stuff like that, is working with various APIs that are really inconsistent and poorly written, and not being able to rely on docs to make tests, but still wanting to make unit tests for all my things. So yeah, so the idea is that if you aren't able to write the test first, don't. Write the initial code first that gets you to the place where you need to be to check it out, and then once you do have an understanding of what the API looks like, then you can write your tests and be like, enforce this object structure and stuff like that.
I know this question is sort of subjective. What is your personal workflow? I know you mentioned in doing TBD, you don't typically want to like start writing a bunch of other functions, sort of stay with the factory kind of stuff. And I found that as I write, especially on like big projects, I'll write something, and then I'm really into that TBD in the beginning, and it sort of branches out. I'm like, ooh, I gotta do this, I gotta do this, I gotta do this, and it becomes like, how far do you go down those branches before you pull back and say, hold on, we gotta write tests?
Yeah, well, I think it's like so usually, yeah, this will happen a lot where it's like because we'll do initial, like we do the initial ideation, and we're like, okay, we think that we need these to do these things. We'll use these units, and they'll take these parameters and that kind of stuff. but most of the time in the development process, right, it's like, oh, I forgot that this part was part of it. And so that now I have to fix this thing too. Or maybe a unit test that I wasn't expecting to break and some other part of the code breaks because of something I wrote and it's legitimately broken. Then it's like, oh, now I need to fix that too. And so it kind of is just a matter of, I do try to go one unit at a time. So like I'll do one unit and then I'll work on the unit, realize that I'll need a different unit to do something else. If I don't need it for that particular unit, I'll just finish the one I'm working on, get the tests all green. And I try to start from like a clean test state whenever I start writing new code or so that's my like, it's my security blanket, right?
So, sometimes I've written tests where I know that a function internally has like branches in it, and I'm gonna write tests that try to tickle each one of those, because I want to make sure that I'm actually getting, that I'm actually hitting all the code paths through it. Do you consider that making demands of the internal logic, or?
Well, I think it's about considering and thinking just really, really carefully about exactly what the tests are meant to check, right? And making sure that we don't accidentally check things we don't actually care about. So like, if the thing that you care about is that these specific functions are called or not called, then when you mock to make sure that's the case, you're not changing the aspect of the test, right?
Like you might have a function that maybe takes an optional parameter, and then like you want to test it with or without that sort of thing. That's more what I was intending. Or something where you know there's an internal threshold, and then it takes it in, and I want to pass in a value that's both below and above that threshold. And then, so that at least to me, that seems like what I want. I want to know that every code path through that function has got a test. So it seems like it's hard to make it a black box thing in that case, but.
Yeah, and I think it kind of goes to what Ryan's point was, which is that the happy path tests are usually we can avoid mocking pretty easily because it's like, okay, we're putting a thing in the database, we know it works, if the thing is in the database. But the sad paths are probably definitely better candidates for mocking because, right, you're.
This isn't necessarily about mocking, it's more just about like how much, like when are you assuming too much about the inside of the unit that you're writing a test for in your view? So.
Yeah, well, I don't know. I'm not quite because I think there's are you, like you're talking about not replacing what the function is doing, but just like spying on it. Yeah. But,
Well, one thing that might is instead of trying to anticipate which code path to execute beside the block, and then writing tests, coverage analyzers should give you a sense of how rich your tests are, right? Fair point. So that's another score you get. You all green checkboxes, but you should be running a coverage analyzer to tell you that, hey, it looks good, you never tested.
yeah, and it's always fun to see the coverage, especially when you're not like tracking coverage. Like I try not to track coverage. Like I'll have scripts that let me get the coverage when I want it, but I don't like constantly keep an eye on it because I don't want to. One of the things like about this is that I consider unit tests more as a development tool than a way to ensure functionality. Like that's still a really important part of what the unit test does, right? Make sure you don't break things. But I actually see the unit test more as a dev and so I'm not necessarily worried about catching every single path. Like if I know that there's like a general error state and I'm going to catch the error, then like I'm generally not too worried about making sure every single code path is caught. But that's just sort of been my experience because because I'm a solo developer, I get to decide all of my things, and so I've just had that blessing. But yeah, that's my.
And I thought I was seeing a version of how you had the stuff set up with Docker for testing with, like, say, relational database that And another approach I've seen used be handy for that is wrapping your functions in brain just lost the word in a transaction. And so then you can, at the end, you can roll back that transaction. So in the meantime, you get to make your change and test whether that change happened. And then you can roll it back, and the next test doesn't have to worry about resetting the entire database or knowing which tests ran before.
Yeah, so generally what I'll do actually when doing database, and it's in the GitHub project, if you go to the GitHub project, I'm actually implementing this, is I will, in my sort of database initialization code where I'm setting up the tables, I will make it so that I can add a prefix to those tables, and then I make it so that each unit test has its own table set. So it's not a database, it's its own set of tables within the same database. But it means that none of the tests ever have to worry even a little bit about touching each other. And so we don't have to worry about like transactions and stuff. We just do that.
Like when you're running these tests, are you running them in random order or particular order?
So so one great thing about Jest is the default behavior is for it to run all the tests in arbitrary order, with whatever it can run first. And that is like the test runs so much faster that way. And that's part of the database stuff is making sure that they're all able to run like that. I think like my personal philosophy is that individual test suites, like describe blocks, right? Basically in Mocha or Jest, should be completely independent. They should not rely on one another. But within a describe block, I think it's okay to make your tests sequential, just because it simplifies so much.
If you're resetting your database or are you losing the ability to pick up there's mutations you weren't expecting, or like some data change that shouldn't have changed, cause the test, different test failure. The ability to detect unintentional.
Yeah, you could, but oftentimes I don't. So what I mean is that like I'll or no, you're talking about like if a different unit messes with something.
Changing data, and one test is changing more records than it should. And those records, like let's say it's blanket
Forgot the word block.
every row in a table, and then that, if you're resetting your database between like tests or some tests, you're losing your ability for another test to fail when that mutation causes that test to work right.
Yeah, so you probably do lose some of that regularity or that capability to catch that kind of thing. Generally, what I'll do is I'll not reset in between each test, but only in between only different test suites. So that kind of helps a little bit in that. We can at least make sure that the unit isn't messing with itself. But also, right, there's still a place for end-to-end and manual testing and things like that. And so the kind of the idea is that we make our units as good as we possibly can. And then when like the client is like, oh, I found this bug, right? Then we can make a ticket, and then we can figure out what is causing the bug, what state that's being put into the unit is bad, and then we can add more unit tests to that unit to check that for that error case. So no like testing system will catch everything, I think. And so it's just a matter of like, I guess, doing the best we possibly can, and then fixing stuff as we realize it's broken.
So the title is Learn to Love. It's liking unit tests a lot. Like, what's the one big thing that makes you like or love unit testing?
It's definitely the sandbox nature that I've been able to develop of unit testing is why I love it so much. Is because I don't get all stressed out of my unit tests and making sure that they're like perfect or anything like that. I use the unit test as a development. And so at this point, right, I don't really know how to do work without, like, I kind of, I don't like not writing unit tests because it just makes me feel unsafe. Like, I feel like I don't know if this works or not. I'm not sure. I can't be sure. So yeah, that's that kind of thing.
Okay, thank you. Okay, yeah, thanks so much for your questions, everybody. Thanks for coming. I think there's still pizza. Please eat it all. Otherwise, I just get free cold pizza. Next month is Ryan. What was it? Okay. So Ryan's gonna be talking next month. CSCD. You should check out meetup.com. That's the place to RSVP for this, for that announcement. So you can RSVP and get pizza. And you want to do the preview? No. Okay. Okay. All right, everybody, thanks for coming. Feel free to hang out for a while, and yeah, see you next time.